Okay, welcome back student. Today we are going to see the next topic, that is minimization of DFA. Okay, today's topic is minimization of DFA. So what we did in the last class? In the last class we did conversion from NDFA to DFA. Okay, example number 4. Now today we are going to see the minimization of DFA. Okay, fine. So here, what is minimization? Why we need this, and why we need to do the minimization on DFA? Okay, so here in this, the common thing is the input we will take as a DFA and we will get the output is minimization DFA. What is this minimization? And minimization DFA is, first, here example, if some work one person is completing the task with 5 states. Okay, with 5 states, and another person, okay, person 1, and here person 2. So person 1 is taking 5 states to reach the final state, and person 2 is taking 4 states, and both will get the same result. Okay, same result. So here in the simple words, if you are doing in the 5 state, that is DFA, so you can minimize, okay, minimize to MDFA, minimization DFA. Okay, but this also based on the conditions, like if we have the A 1 2 3 4 5 states are there, okay, and you can combine this both together. Now it's 1 2 3 4, okay, like this may be a possibilities. It's not like from 5 to 4 only, based on the problem, maybe from 5 to 3, 5 to 2, 5 to 4 is depends on the DFA. Okay, now so here you can combine, but when will you combine? When will you make a equivalence? This is equivalence. Okay, equivalent. So here based on the equivalent, like 0 equivalent, okay, 1 equivalent, okay, and 2 equivalent, so on, n equivalent. Okay, n equivalent. Okay, so what is this? Equivalent, 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 equivalent. Okay, equivalent. So this is here, this based on the equivalent we can solve the DFA to minimization of DFA. So here the main thing, like in the functions, how we will do in transition function, we will take lambda. Example, I am taking example a comma 0, okay, then we will get the next state. Okay, like example a only. Okay, so what is this? A initial state, final state, and if it is 0, it's going to A only, like this. Okay, So this is a transition function. So what is this? This is state, state, comma, string, input string, okay, string string, then we will get the next state. Okay, so this is a formula. This is the formula what we done here. So here also we will take the if you want to make a equivalent, we will take the same thing, a comma x. X is the input string, then we will get the output. Okay, like example A. So this is just you remember why we are doing this minimization. Means if we complete the DFA in minimum number of state, then it is good for us only. For from normal DFA to minimization DFA, we will do with the help of equivalent, 0 equivalent, 1 equivalent, 2 equivalent, and n equivalent. Okay, and here with the help of this, like state input string is equals to next state, we will get, with the help of this we can minimize. Okay, so when we will see the example, then you will get more clear about it. Okay, so here I will go to the example. Before go to the example, here is belongs to, like if you here delta a comma x is the next state is final state, our final state. Okay, or and next is b comma x, also we will get the final state f or a example. So this is equivalent. Okay, what we call this? This is called equivalent. Or delta is a comma x is equals to final state, or you can take not equal to final state or not equal to final state, a and b, then only it will be equivalent. So what is 0, 1, 2, 3? We will see in with the help of example. Okay, with the help of example we will see. As I told you previously, like if we have only x, okay, if we have only x, this means string, and if x is in mod, then this is a length of the string. I hope you remember this. If normal x, that means string. If x in the mod, then we will consider length of the string. Okay, so here when you are do the equivalence, length of the string is very important. If 0 equivalent, length is 0 or 1, 2, 3, based on that we will get the equivalent. Okay, equivalent. So once we do this problem, then we can easily get the understand what is minimization. Okay, so let's go here the example. Okay, and how many state here? A, sorry, here take the pen. Here A comma B comma C comma D comma E. Okay, this is a states. And what is a sigma? This is Q and this is sigma. What is sigma? Sigma is 0, 1. Okay, you can take A and B also, but we are doing practice on 0, 1 only. Because of that I am taking 0, 1. Okay, now what is Q0? Q0 is A, and what is final state is E. Okay, and delta we need to draw here, delta table. So delta table is, we need to make a table 0, 0, 1, 0 and 1. Here first is initially A, we will make a transition table, then it will be easy for us to change to DFA, to minimization of DFA. Okay, from A on 0 is going to B. Okay, A on 0 is going to B. Okay, now A on C, where it is going? A on 1 is going to C. Okay, next B on 0, where it is going? B on 0 is going to B only. Here the next state is B on 0 is going to B only. And B on 1, where it is going? B on 1 is going to D. Okay, next C on 0, where it is going? C on 0 is going to B. Okay, and C on 1, where it is going? C on 1 is going to itself C. Okay, next D. From D on 0, where it is going? Is going to B. Next D on 1, where it is going? D on 1 is going here to E. Next, last one, what is E? E on 0, where it is going? E on 0 is going to B only. Fine. From E on 1, where it is going? Is going to C. So this is a state table of DFA. Okay, now we need to change this into minimization of DFA. Okay, fine. Next, up to here you understand, because already we did so many times this in every example. So this is easy, we draw the table. Now the next is, you need to find the 0 equivalent. Now 0 equivalent, here we need to find the 0 equivalent. So here the first 0 equivalent is very easy. What we need to do here, do separate normal state and final state. So what we will get? Only final state is E. So we will get A, B, C, D, and next is E. E is a final state. Okay, so this is zero equivalent, zero equivalent. Okay, just we are simple, we are separating the normal state and final state. Next, one equivalent. What is one equivalent? Here you need to check A and B. Just check now, A and B is equivalent or not. Okay, A and B. When A is on 0 is going to B. When A is on 0 is going to B, and B is on 0 is going to B. Okay, this is first step. So A on 0 is going to B, B on 0 is going to B, means here if any one of this is equivalent, both are going, both next state is same, then you need to check if A and B is in the both in the same set. Yes, in the both are in same set. Or you can check this also, A on 1 is C and B on 1 is D. Okay, this is going to the same, but here the different, here is different, but any one of this 0 or 1 is satisfy, go to the same state, then this is equivalent. And with that we need to check whatever the state is including to check the equivalent of A and B, that should be in the same set. Let's see, A on 0 is going to B, B on 0 is going to B. This is in the same set. C and D, check the C and D, C and D is also in the same set. That means A comma B is A equivalent. Okay, now check, you can check any one of this with C, any one of this A or B, you can take any one and you will get check the one equivalence with C. So I will check with A on 0 is going to be, yes, C on 0 is going to B, yes, this is same. Okay, now again we will check with the 1 also. A on 1 is C and C on 1 is C. So here B and C, A, B, C is in the same set. So that means C is also a equivalent. Okay, now next, now you can check A and D. You can check if these three are okay, A, B, C, then any one of these you can take and check with the D. So I am going to check with A only. So A on 0 is B, yes, okay. B on 0 is going to B, okay. Now this is going to the same set, same state. Okay, next check A on 1 is going to C and D on 1 is going to C. Now what we need to check? First we need to check same state. Okay, first you need to check both state should go to the same state. Okay, same state, both state should go to same state. Yes, A on 0 is going to B, D on 0 is going to B. So here it is going to the same state. Okay, what is the second point? Point 1, point 2. Here, what is in the point 2? Point 2, all state, okay, all state should be in same set. Okay, should be in same set. What does it mean? A on 1 is a C and D on 1 is E. Okay, is going to E. Now check C, where is C? C is in the same set. What about E? E is in different set. That means A and B is not equivalent. So what we need to do here? You need to make the separate. Okay, E. Clear this? Why this is A, B, C, why we did not include D means here first A on 0 is going to B on 0 is going to B. First condition is satisfying. Okay, next A on 1 is C, B on 1 is D. Second condition is that should be in the same set. A, B, C, D, the same set. This is also applied, condition applied. So that's why A and B is a equivalent. Next, you can take BC or AC. I am taking AC. A on 0 is going to be A on 0 is going to be and C on 0 is going to be. Yes, first condition is satisfying. Next, A on 1 is C and C on 1 is C. This also it is satisfying because A, B, C that all are in same set only, in 0 equivalent. Next, A and D. A on 0 is B and D on 0 is B. Yes, first condition is satisfied. Next, A on 1 is C, D on 1 is E. What is this? All states should be in same set. What the state we got now here? We got C comma E. C is in different set, E is in different set, okay, as well as D, A, B, C, D. So these are in different set. Because of that, we remove this D from the one equivalence because D is not a equivalent set. Okay, fine. So this is we got. Now we need to go to the second equivalent. Okay, this is simple. If you do practice, then it will be easy for you. First check A. Now when you do the 0 equivalent, you need to just write final state separate and normal state is separate. Next, in first equivalent, you need to take the input of 0 equivalent result as an input and you will get the output. Now in the equivalent 2, we need to take input as equivalent 1, okay, and we will get the output. So let's check it. A, B. A on 0 is B, okay, and B on 0 is B. First condition is okay, means is going to the same set only, is going to the same state only. Next, A on 1 is going to C, B on 1 is going to D. Here D is in the different set, D is in different set and B is in different set. So here this is not equivalent. That means A and B they both are not equivalent. So just write here A and give some space and write B. We don't know, these both are not equivalent, maybe this is one set, another set we will get, another set we will get. So here we separated. Next, check AC. Okay, check AC. A on 0 is B, C on 0 is B. Okay, first condition is satisfied. Next, A on 1 is C, C on 1 is C. Yes, this is also satisfied. So A comma C is a equivalent. Okay, equivalent. Next, do this B. So B on C, check the B on C. B on 0 is B. Okay, C on 0 is B. Okay, first condition is satisfied. Next, B on 1 is D and C on 1 is C. Here D is in a different state, so here there is no equivalence to B in the given set. You need to write the same D and E. Okay, so this is a two equivalent equation. Now go to the third equivalent. Just check it. A comma C is a equivalent or not. A on 0 is B, C on 0 is B. So here A on 1 C and C on 1 is C. Yes, both condition is satisfied. So here A comma C is a equivalent, and write it down the same B comma D comma E. So here if you get the same output as previous, then you must stop the calculation, otherwise you will get the same only. Okay, so how many states are here now? Here 1, 2, 3 and this is a 4. So here with the help of equivalent we change to 4 state. Okay, let's make a graph for this. Okay, first make a graph for this. I will erase here. Okay, first one is A comma C, B, D and E. Okay, A comma C and B, C, E, B, D, E. So here which one is the initial state? Here initial state is A, and what is the final state? E. So initial state is A, initial state is A and the final state is E. Okay, so here with the help of this table only we will draw the, because this is a DFA table. Now we got the minimization DFA. Okay, so here just check it. A on 0 is going to be and C on 0 is going to B. A on 0 is going to B and C on 0 is going to B only. So both are going to the same state. Next, A on 1 is going to C and C on 1 is going to C only. So that means like this 1. Okay. Next one is B. B on 0 is going to B. B on 0 is going to B and B on 1 is going to D. Okay. Next, C on 0 is B, C on 1 is C. We finished here. D on 0 is B, D on 0 is B, D on 0 is B and D on 1 is going to E. Last one, E on 0 is going to B, E on 0 is going to B and E on 1 is going to C. E on 1 is going to C. So previously our DFA was like this. Okay, now we change to equivalent DFA with 4 state and the output will be same. So this is called minimization of DFA and this is important to change from one to minimize the state and get the same output. Okay, so this is simple things. This is a simple example. In the next class we will take another example and we will solve the method. Okay, hope you understand. Thank you very much.